and then play the game. So the degrees are the same, so it winds up being a horizontal asymptote at.
What's up, Murphy?
What's up? Horizontal asymptote at 2. Coefficients would be 2 and 1. We have that, and then it's just a matter of picking some spots then. Use 0. At 0, it's 5. Are we okay with that? 0, it's at 5. So 2. At 1, you get 7 over 2. So that would be what? 3 halves?
Yes.
Let's check 2. At 2, you get 9 over 3, so it would be 3. So now you get the idea that the curve is doing this on that side. And then we'll check on the other side of the asymptote. On the other side of the asymptote, we'll try negative 2. When you use negative 2, you get 5 plus negative 4, so it's negative, or excuse me, so positive 1 over negative 1. What is it? Yeah, so you get negative 1. Well, let's do the same thing. We'll try negative 3. So you get 5 plus negative 6, so it's negative 1 in the numerator, divided by negative 2 in the denominator. So what is it? It was positive half, right?
Yeah.
Yeah, that's fine. Because I think this one mirrors it and goes this way. So it should do that. Okay. Okay. So let's talk a little bit about the second part of this unit. What we're going to look at today is basically 2 things. I'm going to try and talk about, we'll save working with this until after we do slant asymptotes, because it doesn't really come up too much today. So we'll save that. Let's talk about what are called slant asymptotes. There's a lot of information on this, but it basically boils down to slant asymptotes can occur. Slant asymptotes are when you have your curves and it appears that they're matching up to some line that's on a slant. Get it? Sorry. The way that you can get a slant asymptote is if the degree in the numerator is greater than the degree in the denominator. That's really all it works out to be. Excuse me. The way that you find them is you use long division. And once you use long division once, it drops in. So if we start with the function, let me show you how this goes. If I start with this, x squared minus x. Stop.
Beat you this time. Or so.
I'm sorry.
That's all right. No, you know, he's the first one today.
So we're going to go through the whole process again. Start with our x-intercepts, vertical asymptotes, horizontal asymptotes, all that kind of junk, see if there's anything they're on, and go from that. So you have f of x is x squared minus x over x plus 1. So you have x-intercept at the zeros of the numerator. So you set the numerator equal to 0. And you have 2 zeros. What's the first rule of factoring? GCF. So your zeros are at 0, 1. Okay. If you added 0, or if you add x divided by x, it doesn't work. You wind up eliminating one of your possible intercepts. Okay. So whenever you're setting your numerator equal to 0, go through it like you're factoring and solving for zeros that way. So you have to remember that your first rule is GCF. So you have x-intercepts at 0 and 1. Vertical asymptote. Vertical asymptote's going to be at the 0 denominator. That's pretty easy. Where's that? -1. Then we go through those rules about checking to see if you have that horizontal asymptote. The degree in the numerator is greater than the degree of the denominator. So do we have a horizontal asymptote? No. What we will get is going to be a slant asymptote. So here's how we figure it out. It's really easy. No, degree was higher. I'm going to use long division. I'm going to use long division to basically I'm factoring out to see what I'm left over with. And once we go down a degree from x squared, I'm going to be left with a linear function in the middle. There may or may not be some remainder, doesn't matter. We're just looking for this next bit. So, how do I turn an x into an x squared? I multiply it by x. Now remember when we did this a little while ago, which one do I put it over? Yeah. Distribute in. And then I subtract. X squared minus x squared, gone. Negative x minus x is -2. And then how do I turn an x into a -2x? Good. Multiplied by -2. And I have a leftover of 2. Now, that leftover really has no bearing on it at all. But you still have it there as that 2 over x plus 1. But this right here is the equation of the slant asymptote of the function. That's how you find it. Okay? That's how you're going to find it. So when you graph this now, I should get you guys a little bit of graph paper to do something like these. Let me separate this up, get a separate sheet. We had x-intercepts 0 and 1. We had a vertical asymptote at -1. Then we had a slant asymptote at x minus 2. That's slope-intercept form. So where do you start?
-2.
Thank you. And what's your slope?
-2.
X, it's X and then the Y. Wait, never mind. I'm done talking.
Wait, so we all forgot what y equals x minus 2 stands for? Thank you. Your slope is 1.
Up to
Have to go back a little bit and remind us. I guess I might have taken for granted that you might have remembered something for 5 years, maybe by now. Whoops. So your slope is?
1.
1. Start at -2 and walk your slope.
I knew it, so.
What's that? Why am I starting at -2?
No, I said I knew it.
So there's my slant asymptote. And then again, it's a matter of taking some points. So let's pick 3. Okay. What's 3 squared? What's 9 minus 3? Okay. So numerator is 6. What's 3 plus 1? So it's 6 over 4, which is 3/2, so that is 1.5. Once you start looking at the table in your calculator or just picking more numbers, you're going to see that it's going to do something like this. But we need to look to see where it's at for the other side. So we just pick something on the other, we'll pick some number on the other side, which we're asked to put with what, -1, so let's pick -2. When you pick -2, you get -2, you square it, you subtract 2, you divide it by -2 plus 1. -2 squared is 4 minus 2 is, so at -2 it's -2. The same thing with, I don't know, -3. -3 squared minus 3 over -3 minus or plus 1. 9 minus 3. Yeah. And so on and so forth. Okay. And you just pick your own points out. I think after it curves itself through. 9 minus 3, yeah, 6.
They're both on top of this one.
Yeah, it should be. Why am I? Did I put it? Oh, it's minus. I did plus here. I'm sorry. This was supposed to be minus. And this was minus. The original problem would have been minus -2, minus -3. So it's supposed to have been plus 3s. This would have been a plus 2. I accidentally wrote down the problem wrong. The original problem was x squared minus x over x plus 1. I actually did plus x. That's what I screwed up. I just wrote it down. So you wind up here at, so it's 4 plus 2, which was 6 over -1, so it was -6. 9 plus 3 was 12 over the -2. Should be at -6 then. Oh yeah, because it's going to belly itself through, just like the other one. When you look at it, so I can do this here. So you wound up with, what was it, -2, -6, -3, -6. What's happening is it's doing the same idea. It's just mirroring itself through. In between 2 and 3, it's continuing to rise up and drop back down. Calculator-wise, you should be able to find a localized maximum, localized minimum, things like that as you're going through. But that's the basic of it here. The basic is to be able to find that slant asymptote. The slant asymptote you're just finding using that long division. It's really not terrible to go through. Let's do it one. Oops, wrong button. We'll do f of x is x squared minus x minus 2 all over x minus 1. Go through the whole thing again. Start with your x-intercepts. Your x-intercepts, you get the zeros of the numerator. Which means I got to factor that. What times what's -2? You add together, get -1. -1, very good. So your zeros are at 2 and -1. vertical asymptote, 0 denominator. Is that x equals 1. Relatively simple. And then lastly, to get our slant, we just have to divide out. So how do you turn an x into an x squared? Multiply by an x. Subtract out, everything goes away, you get a 0 minus 2. At that point, that minus 2 winds up being your remainder. Okay. Excuse me. Because there is no 0x, so this would be plus a 0 if you wanted to think about that. And then you'd have your remainder of minus 2 over x minus 1. So what would be the equation of the slant asymptote? Y equals x. The slant winds up at the y equals x. And you do the same idea about picking some points and bouncing them around. So slant at y equals x. Yeah, I'll use some graph paper today. I got plenty of it. Okay. We had x-intercepts at 2, -1. And we had a vertical asymptote at +1. So, pick numbers. I'll pick 3. 3 squared minus 3 minus 2 over 3 minus 1. 9 minus 3 is 6. Minus 2 is 4. So at 3 I'm 2. With the asymptotes right close to it, you can probably take a guess that it's going to be doing something like this. Let me check the other side. I have, let's use 0. Hey, at 0 we are it's probably, I bet you it's doing the same thing. And then if you look at it in your calculator, no, they hang out together. They really do get along really well. You never see it in the light of this one. The fraction one is, it's that one right there. Yeah. So we had x squared minus x minus 2 x minus 1. There you go. You get the idea of what it looks like. Okay. Table will help you jump around, but a lot of times some of the numbers that you can pick out, you should be able to pick out 2 or 3 of them without too much of a hassle. So, domain on this one again. We write that down. What's my domain? Yeah, all real except for 1, because you had a vertical asymptote at 1. One other little bit is, we'll save that for Thursday. Now, you want me to do one more? Doesn't hurt.
Either way.
The honesty is important. What's that?
One time I tell people for homework, right?
Yeah.
We have all of them.
Try something like that. X-intercept. Are there any X-intercepts? No. Nope. Vertical asymptote.
Oh. Same thing.
So the domain is all real. This one's going to have that slant asymptote because the degree is higher. So you do your long division. Notice I threw a placeholder in for the x value. Make sure you always have one in there. Sorry, that's fine. How do you turn an x into an x squared? Very good. Okay, drop down the next one, which is 0x. How do you turn an x into a 0x? Multiply it by 0. And then you have that plus 5 as your remainder. Therefore, the equation of the slant asymptote is x. Y equals x. So you just plot them through that. Didn't have the x-intercept. It's right there in the folder behind you on the desk. It says flex. Vertical asymptote at y equals x, or y equals 0. Slant asymptote at y equals x. And then it's just a matter of plotting some points. Okay. Did I say y equals x?
Yeah.
I meant for the slant asymptote was y equals x, but the vertical asymptote was at x equals 0. I plotted it correctly. And then it's just a matter of picking some points. Okay. Pick out some points. You got 1. So you have 1 and 6. See ya. 9 over 2 is what? 4 halves? So probably doing this. Okay. -1. Guessing it's going to be -6. Guessing that's going to be -9/2. What you guys have today is just basically all that. You're going to find x-intercepts, domain range, y, the y stuff, and then slant asymptotes. Milo? Milo. Anybody go by Milo?
I know Milo.
Yeah.
Yeah.
You're not equal, that's great.
There you are. Day 2 stuff, knock yourself out. I think there's only like 6 of them. Okay? Yeah.
51 through 56.
Yeah. You guys want a piece of graph paper? Try it. Make maybe a little bit easier to graph.
Yeah.
Okay.
Popping with this.
You really don't need graph paper. I think sometimes for some of these it's a little bit easier to see the curve.
I hate graphic. No paper.
You don't want it. And that's fine. I normally don't use it, but I think at least for the first day it's kind of nice to show you guys how the slant asymptote works. Nothing but the best for you guys.
So did you upload the like thing to the website?
Hey.
Yeah, I don't know why.
Did you hear them?
Oh, I never listened to it though. I never listened to it. I should have.
Did we do that?
Feel bad. I don't
Oh, we forgot to say hi to Devin. Here, watch. Devin's gonna go sliding down the slant asymptote.